Hi, I'm Andy Mutziger, and I'm an air quality specialist with the San Luis Obispo County Air Pollution Control District. And I'm here to talk about a case study that we are interested in presenting to folks on how to uh, improve the comfort of your home and save money with passive attic ventilation and adding attic insulation. So this is a project that I did on my own in Santa Margarita, California. Santa Margarita, California is just north of San Luis Obispo. San Luis Obispo is a town in the Central Coast that is heavily influenced by the ocean climate. But Santa Margarita itself is up in the hills above San Luis Obispo, and its weather is quite varied. We have quite a bit of climate changes or climate zones up there. And so our temperatures in the summertime can be in the hundreds, and in the winter times, we've measured 8 at my house. So it's pretty, it has seasons. And beyond that, on a daily basis, we can have some diurnal changes in temperature that are really significant. They can be 30 degrees, 40 degrees, even 50-degree temperature shifts throughout the day. So in our town in Santa Margarita in the North County, uh, our homes are really heavily affected by temperature changes. And what I found was that our home itself, um, the the attic was just ridiculously hot. And let's move on to the next slide and we'll kind of talk about that. So there are two issues that come with homes that have attics that are just not well insulated or not well vented. The issue that you have is, for example, in our home, uh, we have 33 trusses, and within the 33 trusses on the back of the home, there were only 4 trusses that had holes in there for venting into the attic. Uh, that is just not enough um, ventilation or intake air, inlet air for that attic to be able to escape the heat that gets um, built up in a sunny day. So the goal that we had was to create a lot of extra ventilation within the attic to get that hot air, that blanket of hot air that builds up throughout the day, just to be able to roll out of the peak of the roof by convection. And then secondly, we were interested in adding additional insulation. So this slide here shows what happens when you have an attic that's just not well vented. That attic airspace will just get boiling. It gets 170 degrees or 150 degrees, 140 degrees. And I've been up there in the summertime, and it is just sweltering. And what happens with that is that heat through diffusion just will come down through the insulation that you have in the attic and come down through the ceiling and into the home. So you can have really uncomfortable environments in your house as a result of this attic, this really heavy, high temperature attic airspace. If you can instead get that air to just that hot air to do what it normally does, which is rise up and out of the attic and into the air above above the house, you'll be able to reduce that attic air temperature significantly. And that second picture there in this slide helps to show that. You just have a lot less heat load coming down through the ceiling with a well-vented attic. In addition, if you have additional insulation in there, whatever the attic airspace that is, if it is even 115 degrees, it's going to take longer for that heat to come down through. What we were really seeing before we did this project was in the late afternoon in the summertime. The sun was going down, or it was kind of cooling off outside, but the house itself was just getting hotter and hotter, and because we had a latent effect of that hot air, or that heat rolling through, coming down through the attic, permeating slowly through the insulation. So the result of this is, by going ahead and adding insulation and creating good ventilation in the attic, in the summertime you're going to have reduction in air conditioning, and you're going to have lower utility bills.
Nice. Good Lord.
What's going on?
I don't know. It's
All right, so let's look at the next issue here, the winter issues. So attics that are improperly insulated, in the wintertime, in North County, like what we have, we're using our heater, and that heater is necessary because of the cool climate we have. Well, when the insulation in the attic is minimal, you're going to lose a lot of that heat right up and out of the ceiling and into the attic. So that's an issue. If you can go ahead and, like what we did on our project, add additional insulation to your attic, in your cool climate, that's going to help to reduce the amount of heater use you have and the gas bills that you have. All right, this slide that we're looking at is the 5 steps for this passive attic ventilation project that we did. We didn't actually do all 5 of these. Wish we had done the first one. We missed that. I didn't really know about it before I did the project. And when you start the project, that's the first thing you have to do, is seal all the penetrations in through the ceiling. The second thing is, once you've got those sealed, is to relay the insulation, and ideally, if you can, lay more insulation. The next 3 things are really where you get the airflow. So you've got Soffit vents at the eaves that you need to install. As I mentioned before, our home only had 4 of the trusses with vents. We ended up installing Soffit vents in almost every one of the truss spaces. The next thing is you have to install Rafter vents, and those are vents that allow connection between the soffit and the attic airspace through the insulation itself. So that's a critical step in order to get that airflow through from the outside air, the inlet air coming in, the cooler air coming into the attic from outside. And then finally is a baffled ridge vent, and that's at the peak of the roof. This is where that hot air escapes. As convection dictates, hot air is going to rise. It rises up and out of that ridge vent, and in so doing, it's pulling cooler air from outside into the attic. The baffled ridge vent, the deal with that is, if you have a windy day, as air is blowing over the top of the ridge vent, this baffled ridge vent, it actually creates something called a venturi effect. And that venturi effect draws air up and out of the attic airspace as well. So you have 2 benefits. You got convection going, and you have that venturi effect if you have wind. Anyway, so this is I like this slide. It's Roof Venting 101, and it really kind of tells you a good story on how to get this project done. Next slide, slide 5. The previous slide we were looking at talked about the actual physical steps that you have to do the project. This slide here, there's a lot of work that has to be done before you actually start doing your project, and this is a slide that kind of shows some of that work. The previous slide did talk about some theoretical ideas on defining how much exhaust ventilation you need, or airspace that you need, versus the inlet. I'm not going to get into that too specific. What I did in this case was to kind of match up the net-free area of exhausting at the peak of the roof through the ridge vent, and the net-free area at the soffit. That was what I did. That may not be the optimal, but that seemed to work out okay. And for our project, we ended up having about 8 square feet of net-free area to exhaust the attic airspace from the ridge vent, as well as the soffit. So I did my best to figure out, okay, how big of a hole do I need to cut in the soffit in order to get those two airs, a match between the exhaust and the inlet. So that's what this particular slide shows, is some work to try to figure out, to help you plan out your project. Here's slide 6, and slide 6 is still before you're actually doing your project, in the planning phases. One thing that if your area has something like what we have here in the Central Coast, go talk to some experts. Here we have a group called Empower Central Coast, and these are experts on how to help you make your house more efficient. Had I known about them beforehand, and they will do an energy audit on your house and kind of get you a good sense as to what things are could be done. So anyway, I'd encourage you, before you start your project, to seek out some expert advice from folks like these energy coaches that we have. In slide 7 here, we're actually getting into the nuts and bolts of the project. Sealing all the ceiling penetrations. So I like the picture over on the left-hand slide here. It shows really what's happening if you've got you're heating your home, the inside of your home, and you've got all these air spaces that haven't been sealed. You lose a tremendous amount of heat out of your house in through those penetrations. Through the ceiling, and it's interesting. You really wouldn't think about that because you've got insulation above you in the ceiling, and you just don't really think about that. But truly, it's all about containing or keeping that heat in. And if there's a small hole, that kind of stuff it's going to go through the path of least resistance, and it's going to get out. So sealing is really an important step. It's a step that I missed. It's a step that had I been talking to the energy coaches before I started my project, I would have known about, but I didn't know about it. So again, it's a good thing to go talk to your energy coaches. They can do those energy assessments and help you figure out the best thing for your project. So these other pictures here show you some of the techniques for sealing. I didn't even realize it, but the cracks that you have between the drywall, those taped areas, that's not actually considered very well sealed. So they will go ahead and seal some of that. They'll seal all the penetrations like light fixtures and things like that. All right, we're on to step 2. And before I go on to that, on previous step I was talking about they can be you as a homeowner. You can do it on your own. I did it on my own. Kind of on my own. I did hire a contractor, and I did a lot of the work with that contractor. It was helpful to have somebody else up there in the attic. It would have been impossible to do by myself. Anyway, so this next step here is getting more insulation in your attic. Our area is the climate zone that we have. Title 24 specifies R30, and that's what we had when the home was built. I guess it was built to current standards. But even so, the insulation was actually 24-inch wide insulation when you've got 22.5-inch wide trusses. So it was stuck in there and kind of haphazard, and bunched in, so it wasn't really well sealed. The insulation wasn't in there very tight. So what made sense was to pull that insulation out and put in some insulation that was actually the right width for the truss space. And what I chose was something that was actually pretty easy to work with. Is denim insulation. This was R13, so we went ahead and installed that throughout the entire attic space. And then the next step was to install the other insulation back on top. Once we were done with that, we were sitting at a layer, insulation factor of R43. I guess one last thing is we were able to get a 2014 tax credit for this project for the purchase of the insulation. All right, slide 9. This is the third step, physical step in the attic passive ventilation system. This is installing the Soffit Inlet Vents. And get ready. This is some serious backbreaking work. One thing that you really have to do is get up into your attic, pull the insulation away from the eaves, and look before you cut, because there's stuff up there that you do not want to cut into. There's water lines, there's electrical systems, there's other stuff up there. So please get up there and make sure you pull that insulation out, and then you can start your sawzall work. So as I mentioned before in step 0A, I kind of figured out that what I really needed to do for spacing was about a 22-inch wide or maybe 20-inch wide hole by about 2 inches tall. So that was kind of my goal, was to cut holes in each of the soffits to about that dimension. The way I started that is I used a hole saw and cut holes at spacing so that my total width would end up being 22 inches. And once you got a hole in through the eave, then you can get the sawzall in there and cut out the rest of it. This was one of the hardest parts of this project. Another difficult part of it is, you really need to make sure that your water lines are going to be below the level of the insulation. We had a couple water lines that were actually coming up and almost hitting the sheeting of the roof. So there's some prep work that you really have to do. On the back of the house, you'll see we went ahead and on the far upper left-hand side of the slide, you see the pictures of the soffit. That was this house had an open soffit area. We went ahead and enclosed that, and then put in soffit vents. So the soffit vents connect the airflow between the outside air and through the soffit itself. And you just have to, as you're doing the calculations, you have to make sure that the soffit vents themselves, the ones on the far right-hand side in the side of this picture, matches up, has enough airflow, net-free area that you won't create bottlenecking. We're on slide 10, and this is the fourth step. These are the Rafter vents. So surprisingly, these are, the material cost for this project were not tremendous. So I bought a bunch of these Rafter vents, and we installed them. And the way to install them, if you can take a look at the picture on the right-hand side, you use a staple gun basically, and staple the ridge vent. The Rafter vent to the sheeting itself. And what it's doing is it's creating a chute between the soffit vent, or the holes in the soffit, and into the attic airspace. Then you take and butt the insulation up against it, and ideally you'll cut that insulation at an angle so that it fits nicely up against the Rafter vent. One thing that we did was we did go ahead and modify these a little bit by cutting the rafter vent near the eave itself, and we cut it and folded it back so that it was basically kind of perpendicular to the attic or to the ceiling itself. And that way, we really didn't have to do any cutting on the insulation. It was already coming up against a flat surface. So that worked out pretty well, and it also ensured that we weren't going to collapse the rafter vent and then block the airspace between the soffit and the attic airspace. Okay, we're on slide number 11, and this is the last step in the physical work for this project. Step 5, installing the ridge vent. There's a great story behind these pictures here. This time frame was March 2014, and in Santa Margarita it was 100 degrees in March. It was crazy. So my contractor guy and I were up in the attic installing rafter vents in the morning, and by about 11 o'clock it was just absolutely baking in the attic. And you realize we are up in the attic, we're in Tyvek suits, respirators, gloves. You know, when it's 100 degrees outside and all of a sudden your attic is just getting baked by the sun and the heat, by 11 o'clock we were done. We could not stay in the attic. So we went and had lunch, and then after lunch we decided, well, let's go ahead and go up and cut the ridge vent in. So that's what we did. And this is a good couple pictures here of the ridge vent. This is the garage that we're looking at, so it's perpendicular to the house. But basically, you take your saw and you cut through the roof sheeting. Snap a line and cut through the roof sheeting and the shingles. And in this case, I think we were trying to create a space that was 3/4 inch a minimum wide between the center 2x4 and the outside and the cut itself. And then once you're done with that, you install the ridge vent on top of it. So the good story here is the next day, my contractor guy and I got up in the attic. It was 100 degrees outside again, and we were able to work all day long up in the attic without having to come out, because there was a place for that hot air to escape. It was going out the ridge vent. It was like night and day different with one step. Well, several steps before that, but just cutting that peak off and putting that ridge vent on allowed that hot air to escape, with, of course, the inlet air coming in from outside. So that sold me right away. I was like, oh my gosh, this is fantastic. All right, this slide here, slide 12, is I'm going to suggest to you guys to go ahead and pause this at some point and just look at it yourselves for, kind of study it. There's a lot going on with this slide. I'm going to go ahead and give you some highlights that we see with this. This is looking at the summer benefits of the passive attic ventilation and added insulation. The blue area or grayish area on the right-hand side is basically that's the period of where the system was installed. The left-hand side is prior to the installation. So that's going to be the same on the next slide too for the winter benefits. But basically, what I want to really point out here is the utility use. So in July of 2013, July of 2014, those were the peak times of heat that were happening in Santa Margarita. The utility bill, or the utility usage in July 2013, from use of air conditioning that we had going, primarily a driver of that In July of 2013, we had 579 kilowatt hours that were billed out for that month. In July 2014, we had 342 kilowatt hours billed out. And if you look at the temperatures, they were both, the max temperatures in between those two time frames were almost identical. The average temperature was actually higher in July than it was in 2014 than it was in 2013, but we still had less usage of electricity. That difference between 579 and 342 is about a 41% reduction in PG&E electric use, simply because we have a passive attic ventilation system that was installed. The house was much more comfortable. We weren't having the latent effect of the heat coming down from that hot blanket of air into the house later in the afternoon. We weren't having to run the air conditioner. It was just much more comfortable, and the results are right there. We were using a lot less electricity. All right, we're looking at slide 13 here. This is showing the winter benefits, and again, I'd encourage you to take a moment and pause the presentation here and take a look at this a little more closely. But I'll just give you some highlights here. So before we installed the passive attic ventilation system and the added insulation, in December 2013, that time frame we were using, we used 100 therms for that month. Compare that to December 2014, and our usage on that was 56. So it was actually 102 versus 56. It was a little bit warmer in 2014 than it was in 2013. Not a tremendous amount, but it was a little bit warmer. So what the benefits that you see, the reduction in SoCal gas use was about 45%. Some of that was because it was a little warmer. We weren't using the heat as much because of that. But the bulk of that was because the home was much more comfortable with that added insulation in there, just holding the air, or holding that warm air that we were using from the heater in the home longer and more effectively. So the bottom line is we used a lot less therms, or we are using a lot less therms now in the winter times than we were before. All right, we're on slide 14, and this is some of the take-home messages that I have found that we'd like to share with you. Again, there's a lot on this slide, so you may want to take some time to pause it and take a look at it. I'll give you some highlights here. This project was not tremendously expensive. I had budgeted about $4,000 for the project. When I looked at material costs were roughly half of that relative to the labor costs. Labor costs and material costs were about half. And anyway, it was pretty inexpensive. The one thing about this project is it's a time-consuming project. It's, budget some good time to do this project. It's labor-intensive to get those soffits cut, the holes cut in the soffits. It's really labor-intensive and kind of uncomfortable getting up there in the eaves and moving around. You got to slide boards around underneath you and try not to fall through the ceiling. So it's tight quarters. Anyway, it's a lot of work. You are creating sweat equity, no doubt about it. Again, I talked about the safety equipment that's really kind of essential. And if you're going to do this work, make sure you schedule it for the winter, because even in March when we had 100-degree days, that's not the ideal time to be in there. So what are the benefits? One of the benefits is that I'm really excited that this house has a great venting of the attic in a way that has no electricity use. There's no fans going. There's no noise associated with fans. It's all done passively, either through convection or through the venturi effect with the wind blowing over the top of that ridge vent. It just works. It works great, and it's done in a way that has no real energy use. So that's a nice thing. To me, that's a selling point for the home. The one thing I missed on this project was sealing step one, sealing the attic from all the penetrations into that. Had I done that, I would think we would see even better benefits. So that was a missed opportunity. Okay, this is the last slide in our discussion here on passive additive ventilation, and this is taken to the next step, as we kind of talked a little bit about on the last slide, on new construction. The last slide was all about retrofits. This is all about new construction. As I said, I'm encouraged by the results of our project, that this is an easy solution to reduce utility use in homes. The easiest step for this is to do it when a new set of homes are being built. You are already up there doing this work, so the cost, as we've mentioned, of the venting systems that you have to buy for this is minimal. You're not going to add a lot more labor to put these vents in the process. And it's just way easier to do it before you put the roof on. I mean, it seems like a no-brainer that this would be a really valuable addition to new home construction. The same green home, even commercial structures that we talked about in the previous slide, those features added to these into new construction is going to be a great thing, and this is going to be above and beyond Title 24. So not only are you going to have your owners or users of these properties that have this passive additive ventilation and added insulation projects, they're going to enjoy a more comfortable living environment, less utility use. So those are great benefits. So with that, I encourage you to take a look at this a little more closely, and I'm happy to answer questions. If you have questions, you can contact myself or the Air District here in San Luis Obispo County, California.